So this video is going to go over how to graph a log function. There should be an equal sign in here. The numbers that I'm going to choose are going to come from my asymptote. So back when we graphed exponentials, the asymptote was always the shift vertically. Now the shift horizontally, which is this, is going to give us our asymptote. So because there's a shift to the right 2 units, there's going to be an asymptote at x equals 2. And now we have vertical asymptotes rather than horizontal because it's the inverse of an exponential function, so it's reflected. The numbers I'm going to pick are definitely numbers after the asymptote, and logs are probably easier to graph in the sense that you know which x values to choose because they're always going to come after the asymptote. Before, our asymptote was hitting at a y value, so that didn't really matter. Now our asymptote's at x equals 2, so I'm going to plug in numbers maybe 0.5, 3, 4, 5, 6, maybe 9 because of the power of 3, and we'll go from there. Cut this down a little bit. I always want you guys to plug in one decimal point right after the asymptote, like 0.5, just so that you see numbers coming closer to the asymptote. If you don't do that, you're not going to see anything near the asymptote. You're going to see a point a whole unit away from it. So I'm going to plug in numbers after the asymptote. And what that looks like is log base 1/3 of 2.5 minus 2, which is log 1/3, log base 1/3 of 1/2 or 0.5, whatever works for you. So that you're just going to type into your calculator as log of 0.5 divided by log of 1/3. And that gives you 0.6. And you're going to get crazy decimals for this because they're logs that you don't know how to evaluate. So that's going to be 2.5 comma 0.6. So approximately right there. So closer to my asymptote, but you're going to need to draw the rest of the function afterwards. So now we're going to have log of 1/3, log base 1/3 of 3 minus 2, which is log base 1/3 of 1. Anything with the big number 1 here is going to be 0. 1/3 to the 0 is 1. So that's 3, 0. Okay, and then 4 log base 1/3, 4 minus 2 is log base 1/3, 2. And you're going to do log of 2 divided by log of 1/3. And you get negative 0.6. So 4, negative 0.6. Okay, it's kind of looking like a curve, almost like an exponential. Log base 1/3 of 5 minus 2, which is log base 1/3 of 3. And 3 to the first power is 3, but this is 1/3, so 1/3 to the negative first power is going to be 3. And I can evaluate that in my head. You could have used a calculator, but on the test, most likely for ones like that, you won't have a calculator. To make a function table, you will have a calculator. So 5, negative 1. Log base 1/3, 6 minus 2 is log base 1/3 of 4. And that would be in your calculator, log of 4 divided by log of 1/3, which is negative 1.3 approximately. 6 comma negative 1.3. And then I skipped ahead to 9 because I'm going to keep getting decimals, but I know that in my head I can do, actually I won't be able to do 9. I'm going to want to plug in 11 to get 9. So that's not helpful because it's not on my graph. So you could do 9 just so that you get a point a little bit farther ahead. They're so tiny here. So we get log base 1/3 of 7. So what I was thinking was that that number was going to be 9, but it's not. So now we're going to do log of 7 divided by log of 1/3. And you get negative 1.77. So still pretty small number. Oh, okay. And then you could keep going from there, and they're going to keep getting pretty small. So what's important is that when you draw this, it's not just like that. That looks like a square root function. You have to approach the asymptote just like you know that it does. So make a nice curve and show that it approaches the asymptote. The problem is that every point in there is very small. It's anything between 2 and 3, and you're not going to plug in 2.1, 2.2, 2.3 unless you want to, but we do need to show that it approaches the asymptote. So that's what that graph looks like. Now here, as the range is going to be negative infinity to infinity, because it goes up forever and it goes down forever, the domain is now going to be affected by the asymptote, and the domain is going to be 2 to infinity. The end behavior as x approaches infinity, nope, this one. As x approaches infinity, f of x approaches negative infinity. So previously they gave you the x approaches one, now they're giving you the y approaches one. So as my graph goes down, x gets bigger. As my y values go up, x goes to negative infinity because we're going backwards. My x-intercept is when I plugged in 3. I got 0 when I plugged in 3. So that's my x-intercept. And the asymptote is now x equals